Okay, so good morning, class. Today we are almost going to wind up the second unit. Okay, so maybe after this today's class, so one more class I may need. Okay, so maybe by tomorrow I will finish this chapter 2. Hmm? So anybody else solved that yesterday's problem, whichever I given it as a homework? Hmm? Rohit, Rohit Kadgiri.
Yes, sir.
Have you solved that problem?
No,
No.
no, sir.
What's the problem? Like whether you understood the concept?
So yesterday I was not attending class, evening class.
Evening class. So you should attend, no? No? We are taking so much hmm, trouble to make you convenient, but if you're not interested to attend the class, then it will be from your fault, no?
Yes.
Hmm? So see, the videos I already uploaded in the Google Classroom. Okay, so you refer them, uh, and then still if you face any problem, let me ask. You can ask me. Okay, so any other anybody else? Suraj Angri, Suraj, are you there? Hmm?
Sir, sir,
Yeah. What about yesterday's problem?
sir, yesterday I did not attend any classes, sir.
Why?
I am ill, sir.
Illa. Okay. So who else? Savitri.
Not attended yesterday.
Okay. So many people not attended. Okay. Swapna Bagli. Swapna, are you there? Okay. So no issue. So I will solve that problem. Uh, then we will see how it will go. Hmm? So before solving, just I want to summarize this consolidation settlement. Okay. So I will add here summary of consolidation settlement. Okay. So yesterday, what we saw to calculate this consolidation settlement, what are the things we need? First and foremost thing is you should have these these compressibility parameters. Okay, so once you have compressibility parameters, then I can uh, uh, solve the I can calculate this consolidation settlement. Okay, so wait a minute. Okay, so okay, so first we have seen these compressibility parameters. Hmm? Compressibility parameters. What are those compressibility parameters? Can anybody tell me? First one is your coefficient of compressibility. Coefficient of compressibility. Okay. So how we found out this coefficient of compressibility? If you draw a graph between your White's ratio, that is E, versus your effective stress. If you plot a graph between White's ratio versus effective stress, So I will get something like this. Like this curve I will get. So the slope of this origin compression line will be my AV. Okay. So AV is equal to, what is the formula? Delta E by delta sigma dash. That is change in White's ratio with respect to change in effective stress. Okay. So then what is the second parameter we have seen? So compression index. Compression index, that is CC. Okay, how we got this CC value? If I plot a same E versus sigma plot but in logarithmic scale, so this is E and log of sigma dash. Okay, now this whatever this curving nature is there, now it become a straight line. Okay, so it will become a straight line like this. So the slope of this line, origin compression line, is CC value. Okay, so this CC is nothing but the change in White's ratio divided by the change in effective stress, logarithmic scale in terms of logarithm. Okay, so log of sigma 2 by sigma 1, sigma 2 dash by sigma 1 dash. Okay, so this is compression index. Then what is the third term? Coefficient of volume compressibility. Coefficient of volume compressibility. Okay, so what is the symbol? Coefficient of volume compressibility, it is MV, right? So your MV is equal to what? Your volumetric strain divided by volumetric strain divided by what?
Change in stress.
Change in effective stress. Very good. So change in effective stress. Okay, so that is nothing but your delta V divided by V is nothing but your volumetric strain divided by delta sigma dash is my change in effective stress. Okay, so this can be written in terms of U1 height also, because since I am considering it as a 1D consolidation, so your volume is in the only one direction, that is H direction, because other two dimensions are unit 1. So that is delta H by your H divided by delta sigma. Okay, so I have a relation between your coefficient of volume compressibility and compression index. Okay, so what is that? So my MV also can be written as AV divided by 1 plus E naught. This also I can write. And what is the fourth parameter we have seen? What is that? Coefficient
of recompression.
Yes, recompression index. Coefficient of or only recompression index also you can write. Okay, recompression index. Okay, so what is the symbol? CR, or even some in some textbook they will use as a CS, coefficient of swelling index also they will call. Okay, the recompression index, CR or CS, whatever you want. So this is nothing but the slope of this line. Okay, so this whatever this recompression line will be there, no? So this is recompression line and this is origin compression line. Okay, so if I take the slope of this line, then this is my CR. Okay, so CR is nothing but again delta E by log of sigma 2 by sigma 2 dash by sigma 1 dash, but it is in the range of recompression line you should take. Okay, that slope should be taken in this recompression line. Okay, so whenever I am talking about compression index, then you should take in the this VCL, origin compression line. This is recompression line. Okay, So once I have these all the compression indexes, now the next thing is I should know whether the soil is normally consolidated or over consolidated. Okay, so some important what I should call terminologies I should remember. So important terminologies. Okay, so first one is what? What is the first one? Normally consolidated. Normally consolidated clay or soil. Okay, so what is the abbreviation? NC. So can anyone tell me what is normally consolidated soil? If the
OCR
present,
is equal to 1.
yeah, OCR, if at all my OCR is equal to 1, then I can call it as a normally consolidated. Okay, so this is one way of defining normally consolidated. But what is the other way? So like if your if the present effective stress, present let me where is this? I will write it this one later. Okay, so if the present effective overburden stress is the maximum pressure that soil has been subjected in its geological history. Okay, and that means whatever present load is there, that itself is the maximum pressure it has ever seen. Okay, so those kinds of soils are called normally consolidated soil. Okay, so if I want to define in terms of my over consolidation ratio, OCR, then if my OCR is equal to 1, then the soil is called as normally consolidated. Okay, so this is nothing but your pre-consolidation stress is there, no? That is equal to my present vertical stress. Okay, so pre-consolidation stress is equal to present vertical stress. If that is the case, then the soil can be called it as a normally consolidated soil. Okay, so these normally consolidated soil undergo relatively larger settlement. Okay, so why I am using the term relatively? It is relatively means it is compared to the OC soil. Okay, so what is the second definition? That is over consolidated soil. Okay, so over consolidated soil. What is the symbol? That is OC soil. How I can define over consolidated soil? Tell me. If the present effective overburden stress is less than the stress which soil experienced in its past geological history. Okay. So if I want to tell me in terms of define in terms of OCR ratio, OCR is greater
Greater
than
than 1.
1. Okay, so then also I can call this as over consolidated soil. Okay. So that means your pre-consolidation stress is that is greater than your present vertical stress. Okay. Now, what is OCR? So OCR is nothing but my pre-consolidation stress to the present vertical stress. Okay. Okay. So then we have seen some formulas to calculate the these consolidation supplement. Okay. So formulas to calculate what consolidation settlement. What is the basic formula? First, tell me. What is my basic formula? That is my delta H by H naught is equal to delta E by 1 plus E naught. Okay. So delta H is equal to, this is nothing but my consolidation supplement. Okay. So that is SC I will write. Okay. So is equal to H naught into H naught divided by 1 plus E naught, okay, into delta E. Okay, so this is the first equation which I can use it to calculate the consolidation supplement. Okay, so this is the first equation. What is the second equation? So I can use your AV. Okay, what is AV? AV is nothing but coefficient of compressibility. Okay, so what is, after all, what is AV? Tell me, what is AV? AV is nothing but change in void's ratio to the change in effective stress. Okay, so now you put this equation here. So in wherever this delta E is there, now in this delta E, now you put AV by delta sigma. So my SC is, now it will become it will become like AV divided by 1 plus E naught into delta sigma dash into my H naught. Okay, so this is my second formula. Okay, if in the problem if they given AB value, then you should use this equation. Okay. Then there is another formula by using your MV. Okay, so what is MV? MV is nothing but coefficient of volume compressibility. Volume compressibility. Okay. So what is MV after all? MV is equal to AV divided by 1 plus E naught. Okay, so you put it in this equation. So AV by 1 plus E naught is nothing but my MV. So MV into delta sigma MV into delta sigma dash into H naught. Okay, so this is my third equation to calculate the consolidation settlement. If they in the problem, if they given you the volume compressibility, then you should use this equation. Okay. Now, what is the fourth way to calculate the consolidation settlement? By using compression index, that is CC. Compression index. So CC is nothing but, what is CC? Delta E divided by log of sigma 2 dash by sigma 1 dash. Okay. So now if I put this one in this equation. In this equation, if I put this delta E, wherever my delta, sorry, not this one. Where is my delta E? Yeah, this equation. In this equation, where in the place of delta E, if I put Cc into log of sigma 2 by sigma 1 dash, then I will get the fourth equation. So put in equation number 1, I will call. Okay, so this is my equation number 1. This is my equation number 1. If you put in this one, then I will get what is the formula? This is very important formula. Okay, so I will write it in red. So this is important. Almost 99% of problem will be asked based on by giving you the CC value. Okay, so if you forget these formula also, that is fine, but you should not forget this formula. This is very important. So SC is equal to CC or H naught divided by 1 plus E naught. So H naught divided by 1 plus E naught into CC into log of sigma 2 dash by sigma 1 dash. Okay. Or what is sigma 1 dash? Sigma 1 dash is nothing but your sigma V naught only. Okay, sigma V naught dash, that is present vertical stress. So H naught, what is H naught? H naught is thickness of clay layer. Thickness of clay layer. And sigma 2 dash is nothing but your present vertical stress plus change in the effective stress, that is delta sigma Z. I can write. So this is change in effective stress because of what? Because of your foundation. Okay, so anyway, sigma V naught is nothing but your present vertical or overburden stress. So overburden stress or present effective stress also I can call that. Present effective stress. Okay, so this is important formula, you should remember always. Okay, how you can calculate this CC value? CC value can be calculated by your liquid limit equation, that is 0.009 into liquid limit minus 10. Okay, so this liquid limit will be in terms of percentage. Okay, so this is what we have seen till now in our consolidation supplement chapter. So important takeaway from this discussion is these definitions of these compressibility parameters. Then what is NC, what is OC, and what is OCR, and how to calculate the consolidation supplement. There are 4 ways to calculate consolidation supplement, but this 4th one is very important. Okay, so almost 99% of your problems based on this formula. Okay. Okay, so coming back to that problem. Okay, so this problem I was talking. So let me solve this problem. Okay. So what they're telling, a footing of a water tower carries around 910 is 3.6 meter by 3.6 meter square. It rests on dense sand of 9 meter thickness over 9 meter thickness overlying a clay layer. Okay, so that means dense sand is overlying on a clay layer. Okay, so this is your foundation. I will write. Okay, so this is my ground level. This is ground level. Okay. So how much load it is applied? That is capital Q. See, in terms of weight they given, okay, not a stress. Okay, so if they given in terms of stress, that is a small q. Okay, now here they given weight, so that is capital Q is equal to 900 ton. Okay, so the size of the footing is 3.6 by 3.6 meter. So it rests on a dense sand of 9 meter thickness overlying a clay layer of 3 meter depth. Okay, so this is clay layer. So what is the depth of clay layer? That is 3 meter clay, and what is the thickness of your sand? This is sand layer. Okay, so this is my sand. So 9 meter thick. The depth of foundation is 1.5 meter. Okay, so this is my 1.5 meter depth. Okay. So 1.5 meter. The clay layer overlies the hard rock. Okay, so that means here there is a hard rock. So this is my hard rock. Okay, so from this onwards, I will get this is hard rock. Okay. So the liquid limit of clay is 54%. Okay, so the liquid limit is 54. Okay, so sometimes I will write LL, or this is nothing but your WL. Wide ratio is how much? That is initial wide ratio only 1.08. The saturated unit weight of sand and clay are, so the groundwater table is here. So gamma sat of sand, this is of sand layer, is 18.9 kilonewton per meter cube. 18.9 kilonewton per meter cube. And what is the unit weight of clay layer? 17.9 kilonewton per meter cube. Okay, so this is where I should write here. Okay, so gamma sat. How much? Gamma sat of clay is 17.9 kilonewton per meter cube. Okay, so assume the load distribution is 2 vertical to 1 horizontal. Assume that site is flooded. Okay, so site is flooded means the groundwater table is at the ground level. So this is my ground level. Okay. Now let us solve this problem. How we can start? So first write down the formula. What formula we should use to find out the consolidation settlement? SC is equal to CC divided by 1 plus E naught, not CC, H naught I will write. Okay, so H naught divided by 1 plus E naught into CC into your log of sigma 2 dash by sigma V naught dash. Okay, so what is my H naught here? What is H naught? What is the thickness of clay layer here? 3 meter. So H naught is 3 meter. And what is my E naught? E naught they given here 1.08. E naught equal to 1.08. And what is CC? CC I should find out. CC is equal to 0.009 my liquid limit minus 10. So 0.009. What is the liquid limit they given? 54%. 54 minus 10. How much? CC, how much you are getting?
39.6.
0.396.
Yeah, 0.396. 0.396. You should put it in percentage only. Yeah, this liquid limit. Don't convert it into decimal because see this formula is given by Skempton. There was a scientist called Skempton. Okay, so he has given this formula. So the what he used was this liquid limit. He used it in a percentage only. Okay, so that's why I should put your liquid limit in percentage only. So this is my CC value. Okay, so this I got, this I got, this I got. Then what is my sigma 2? Or before that I will calculate sigma V naught. Okay, so sigma V naught dash at the center of the clay layer I should calculate. Okay, so let me draw a center line here. Okay, so here I should calculate my sigma V naught dash and delta sigma. Also delta sigma Z I will write. Okay, those things I should calculate here. Okay, so first let me calculate sigma V naught. So sigma V naught is nothing but your overburden pressure. Okay, so whatever soil is present above this middle of the clay layer, no, that's weight. Okay, so that's weight, buoyancy weight you should see because the soil is under water table, no, so that's why its density will reduce. So you have to always take the buoyant what do you call buoyant's unit weight they will call. Okay, that is gamma dash. Okay, so this gamma dash is called as buoyant unit weight, which is nothing but your saturated unit weight minus the unit weight of water. Okay, so sigma V naught is equal to first take this unit weight of sand. Okay, so 9 into saturated unit weight, how much it is? 18.9. 18.9 minus my unit weight of water, that is 9.81 plus this is middle, this is 3 meters, so middle of the clay layer means 1.5. So 1.5 times your saturated unit weight 17.9. So 17.9. So let me write it plus 1.5 into 17.9 minus 9.81. Tell me how much you are getting sigma V naught dash. How much? Hmm?
93.94.
93.94 kilonewton per meter cube. Okay, very good. So next, what next? I have to calculate this sigma. What I written? Sigma Z I written here. Sigma 1 it is. Sigma 1 dash I will write. Okay, so sigma 1 dash. Okay, so your sigma 1 dash is nothing but what? Your sigma V naught dash plus sigma V naught dash plus delta sigma. Okay, so now I have to calculate this delta sigma. Okay, how I can calculate? Using that 2:1 method. So the delta sigma z I will write. Okay, so this delta sigma z can be calculated using 2:1 method. Okay, okay, so z value is this one. This is my z value. So that means the vertical distance between your footing and the middle of the clay layer. Okay, so this 9 meter, in this 9 meter I have to deduct 1.5. Okay, so that is 7.5. 7.5 plus this 1.5, again 9. So this is z is equal to 7.5 plus 1.5. It is equal to 9 meter. Okay, so like this, the distribution will be there here. Okay, so this distribution is 2:. Let me draw one rough figure here. This is my foundation. This is my foundation of a size. How much size it was? 3.6 by 3.6. 3.6 by 3.6. Okay, so this here was my center of the clay layer. So this is my center of the clay layer. Okay, so what was my z value here? My z value was 9 meter. Okay, so this is how the distribution of the load will be there. Okay, so what is this distance? My width of the footing. Okay, so 3.6. So here the distribution of the load is 2:1. That means for 2 vertical there is a 1 horizontal. So now for z vertical, z is my 9 meter. Okay, so for 9 meter, 9 vertical, what is my horizontal distance? So 9/2, right? So 3.6. So this total distance this is 4.5 meter. This is nothing but my 4.5 meter, and this is also 4.5 meter. Okay, so now total of what will be the distance here? 9 plus 3.6. So total is 12.6. Okay, so my delta sigma z is nothing but q times q divided by, what is the formula? B plus z into L plus z. So what is q here? How much load they told? 910. Okay, so that you put it in terms of newtons. So so 900 ton. It is in ton. So to convert a ton to the kilonewton, then I have to multiply by 9.81 divided by B plus Z. Oh, what is the B plus Z? 3.6 plus 4.5 plus 4.5. Okay, so that is nothing but 12.6 into. So my L is also 3.6. Okay, so this side also my L. L is also 3.6. So that 3.6 plus 4.5 plus 4.5 again. So that is 12.6. Okay, so tell me how much you are getting delta sigma z. So delta sigma z is equal to
55.61.
55.61 kilonewton per meter square. Okay, now you put everything you got now. Okay, so you know delta sigma z, and you know sigma v naught, you know everything, you know. Okay, so simply now, so this value you should put in the equation. And this is my delta sigma z. Delta sigma z is here. This also I should put it in my equation. Okay, so SC is equal to CC by 1 plus H naught is how much? H naught is 3 meter, no? So 3 divided by 1 plus E naught. What is E naught? E naught is 1.08. So 1.08 into CC. CC, how much we calculated? How much we got CC? 0.396. So yeah, 0.396 into log of sigma v naught. Sigma v naught, how much? 93.94. So 93.94 plus my delta sigma z is 55.61 divided by sigma v naught, 93.94. So tell me how much you are getting. SC is equal to 0.1115. Okay. So this is my answer. Okay. Any doubt here in this problem? Yes. Any doubts? Rohit?
Yes, sir.
Have you understood the problem?
Yes.
Any doubts are there?
No, sir.
Okay. So yeah, here there is another problem. So this you solve it on your own. This I won't solve it. This you have to solve on your own, and this will be the part of your assignment question also. Okay, so this I will put it in assignment. So answer I will write here. So you should get consolidation supplement. So SC is equal to 0.48 meter. Okay. So today what I will do, I will compile all the examination question papers, questions from your unit 1 and unit 2. Okay. So I will put them and make it as a first assignment. So maybe by today evening I will send that assignment questions. Okay. So you should be able to submit that maybe before your IA test. So I will anyway in that itself I will mention the due date. So within that date you should submit your assignment, first assignment. Okay, so this first assignment will include all your video questions from unit 1 and unit 2. Okay, you should take them very seriously because as you know, the video has a tendency to repeat the questions of your previous exam problems only, or questions only. Okay, and also I will stick to that only for your IA test also. So I will pick the IA questions from those assignments only. So you should take assignment very seriously and then solve them. So, and one more, my humble request is you should not copy from somebody else. Okay, so if you have any doubt, directly you can message me, then we can discuss, and I can able to, so that your queries can be answered. Okay, so don't copy from your friends, solve it on your own. So if you have any doubts or any queries, if you want to ask me, you are welcome to ask at any time. So this is what I planned today. So there is a very small portion is there. Okay, so that I will cover tomorrow. So till now, what we did, we have calculated the consolidation settlement for the normally consolidated clay. Okay, so if you have a over consolidated clay, then how to solve? Okay, those things we'll see in the tomorrow's class. But I want to remind you that whatever in exams the questions asked, so they all are based on your normally consolidated clay only. So then they never asked over consolidated clay. But to be on complete side, what I will do, I will take one over consolidated problem, and then we will solve that. So tomorrow we'll solve that problem. So I will stop recording here.